Okay, so each of these equations can be rewritten. Well, your V prime can be written dV dt. Okay? And then you can divide through by m. It's more or less optional. Okay, might be easier if you keep the m there and do the integral and so forth that we're going to get. But I went ahead and divided through by m, and that's really just a matter of taste. Then these equations are both very clearly separable. This one is also clearly a first order linear. But this one is absolutely not linear because of a v squared here. Okay? So we could solve this one as first order linear. We can't solve this one as first order linear, but it's clearly separable because if we divide both sides by everything here, we get dv over that. We get all the v's on this side. And then we can multiply by dt, get all the dt's over here. You're not really multiplying by dt. I remind you, you're dealing with differentials. But you can treat it as if they're algebraic quantities. Best to keep in mind that you're really kind of a little fuzzy mathematically when you do that. But if you're going to be an engineer, you're not going to care anyway. It works. Even with mathematicians, it works. Okay? And you got to go fairly deep into stuff before you see what it does. Okay, well anyhow, that's a little bit of a digression. So we can say, in this case, dv over g plus delta over mv equals negative dt. Over here we can say almost the same thing, except must be time for classes to change or something. Hey David, a couple of friends of mine. Okay. Okay, makes sense?
Yeah. And so we don't need to do integration by parts right here, though.
Well, you're going to do something different with this one than you do with this one.
Right.
Okay?
Uh-huh.
So you're going to have to think about what you would have to do. Okay? What technique are you going to use to integrate this? What technique are you going to use to integrate this? Okay? Well, this one's in a lot of ways easier.
Yeah.
So what are you going to do here?
Well, for this one, can't we make a u sub?
Yeah.
For the left one.
Yeah, just let u equal this whole thing.
Right.
You're going to get dv equals m over delta du. Okay?
Right.
Now, it's going to integrate very easily, right?
Mm-hmm.
What are you going to do here?
I was thinking we'd have to use integration by parts for g plus.
I'm not sure integration by parts is going to be much help. I think you're going to have to go to completing a square
Oh, yeah, I guess we could do that.
and or partial fractions. Okay?
Right.
So, and actually, you know, I just realized when I look at the partial fractions of this, I really want to see a minus there. Because it's going to be kind of just about impossible to integrate that with partial fractions. You have to go to an arctangent or something. Okay? When I wrote this equation down, I was careless. Okay? I said minus gamma v squared. Okay?
All right.
Well, if your velocity is in the downward direction, that should be plus gamma v squared. Because v squared is going to be positive whether v is positive or negative, isn't it?
Right.
Okay? So I should really say this is plus gamma v squared, which will make it a minus here. So now you can factor the silly thing. Okay? Hit a difference of two squares.
Right.
Okay? And the thing then we got to say is that v, this occurs when v is negative. In other words, when you're moving in the same direction as your gravity, because this has to have the opposite sign to this, because this represents the drag force. Okay? Drag force is going to be in the direction opposite your velocity. If your velocity is in the downward direction, drag force has to be in the upward direction. Whereas gravity, of course, acts in the downward direction. Okay? If V was greater than 0, because you can have drag force if you throw something up in the air, and then the drag force would be in the downward direction, the same as gravity. Okay? So you would have this if V is in the direction opposite the gravitational acceleration. Okay? So you really have two different equations in this case, and I was a little careless when I wrote that down, so make sure we understand this. Okay? Well, fortunately that makes this a lot easier to do. But you have to use partial fractions. Okay? So, see what you get for this one first, and then if we have time, which we probably won't, because you've got to leave for class in about 5 minutes. Then see what you can do with this one, and if we don't have time, work it out. If you got a question on it, bring it to lab Friday if you need to.
All right.
Okay?